All right, ladies and gentlemen, today we're going to be talking about right triangle trig problems. These are the basic ones, so this is to get a feel for what we're doing. Excuse me. So from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia, sorry, the angle of elevation to the top of the building is 65 degrees. Find the height h of the building. So this do now is something we've done before. So I'll do this in red so you guys can see better. This is your theta. So labeling is important. That's 65 degrees. Now, I prefer you label everything before you get started. So this is your adjacent. I hate that they labeled this h. This is not your hypotenuse. This is your opposite. And this is your hypotenuse. Okay, now they decided to label it h because of height, but that's fine. We're going to label it as opposite. Okay, so now they're asking us specifically for the height of the building or the opposite side to the angle. Well, we have the adjacent and the opposite. Those are the two things we're trying to figure out together. So if we think of so, ka, and toa, well, we didn't use hypotenuse at all, so we're doing toa. So this would be tangent of whatever angle they gave us, or in this case, 65 degrees. And that equals opposite over adjacent, and that is 340 feet. Well, the only way to get opposite all by itself is to multiply both sides by 340. And so now our opposite is 340 times tangent 65 degrees. Plug and chug that into the calculator because I know I'm not a supercomputer, so I can't figure that out. So 1,372.48. Make sure you write units, which is feet, and we're done. There's your do now, okay? Now here's some things we got to read right here. So it's all about the angle of elevation and the angle of depression. The angle of elevation is the angle through which the eye moves up. So eye moves up from the horizontal to look at something. That's this right here looking at George Washington. And then the angle of depression is literally the opposite. It's when your eye moves down from the horizontal to look at something from below. So if you're on a cliff and looking at a boat down below, that's the situation that's going on right there. So then here's a question. What do you notice about the angles of elevation and depression in this situation? Well, if you're looking at each other, this angle is the exact same as that angle. So I would say they are congruent because they are interior angles. Sorry, interior alternate. I think I got that wording backwards. Sorry. Sorry if you have to erase this or if you wrote in pen. Because they are alternate interior angles. There you go. That's the wording. My bad. It's been a while since geometry, but that is the geometric reason for it. Hopefully you remember that. So then right here, we have two examples that we're going to work with. One with the angle of elevation and one with the angle of depression. So first we have our situation, the angle of elevation from the buoy to the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 5 degrees. Find the distance x from the base of the lighthouse to the buoy. Well, first let's draw out a triangle. So that goes there. Actually, it's a little bit better. And then they want us to, there you go. There's our situation. We know that this is 130 feet. It's also our opposite. We're trying to figure the distance from the base of the lighthouse to the buoy. So that's from here to here. So that is our adjacent, which we will label x. And then theta is 5 degrees. We didn't even touch hypotenuse. So since we didn't touch it, we know it's not going to be so or ka. So no sine or cosine. It's toa. So now let's see. We have tangent 5 degrees equals opposite over adjacent. So 130 over adjacent. Now here's a trick that I like to do because we're trying to solve for adjacent, but it's in the bottom of the fraction this time. So I'm going to divide this by 1 and make it into like a pseudo fraction and then just flip both upside down. So this would be 1 over tangent 5 degrees, and this would be adjacent over 130. Now it's easy to multiply times 130 and get adjacent by itself. So now our final answer would be adjacent, or x. In this case, you could say x equals 130 over tangent 5 degrees. And as I mentioned earlier, unless you're some kind of supercomputer, do this in your head. But for the rest of us, 1,485.91. And I'm not that fancy, guys. I use the calculator. Okay, just don't forget feet. You got to write units or else you don't get your points. Okay, now here we have one with the angle of depression. Now, I know it says find the measure of each angle. It's just of the angle. It's just one example. You'll have more on the next page. So let's see. Label. Here's your hypotenuse, even though it's on the bottom, but it's the slanted one. Here's your opposite, and here's your adjacent. And they want us to figure out the angle. Well, we have an angle. We have opposite and hypotenuse. So, ka, and toa. We're obviously using sine this time because we have opposite and hypotenuse. So we know that sine theta equals opposite over hypotenuse, so 2.9 over 11. Sorry for those of you who wrote in pen, I'm going to scooch this over a little bit, just a little bit, because to get rid of the sine, to get theta all by itself, I'm going to put this inside of an inverse sine, which I got to do that to both sides. Sine and inverse sine cancel, and so now I'm left with theta equaling sine inverse of 2.9 over 11. Again, you supercomputers out there, feel free to calculate this in your brains. For the rest of us, theta is 15.286. Watch out. If we were to just write this, you would get it wrong. And the reason is because of this sentence right here. Round to the nearest tenth of a degree. You have to round to the specifications that are given. So 15.3 is your answer. All right, ladies and gentlemen, you guys are in charge of the next page. I'll help you out during class if you need it. Have a wonderful evening. Good luck.